Welcome to Public Health on Call, a podcast from the Johns Hopkins Bloomberg School of Public Health, where we bring evidence, experience, and perspective to make sense of today's leading health challenges. If you have questions or ideas for us, please send an email to publichealthquestion@jhu.edu. That's publichealthquestion@jhu.edu for future podcast episodes.
Researchers in China recently reported in a journal that a new bat coronavirus has the potential to spread to humans. While the finding was important, other scientists expressed concern about how the research was done. In this episode, Johns Hopkins virologist Dr. Andy Pekosz returns to the podcast to talk with Stephanie Desmon about how biosafety standards for labs vary around the world and what that could mean for studying future viruses with pandemic potential. Let's listen. Andy Pekosz, thanks so much for joining me.
Oh, as always, my pleasure.
In March, some researchers from Wuhan, China, published in the journal Cell that they had been working with a bat virus, so HKU5 coronavirus, and they were discovered that it could spread to humans. And so, of course, this raised concerns about, could this be a new pandemic? But really, when I asked you about it, you said that's not really the question.
Yeah, the real question there was, this kind of work goes on a lot, right? I mean, we want to get some sense of, out of the thousands of viruses that are out there in other animal species, what percentage of them are close to being able to infect humans, right? And so this study characterized HKU5, a couple of other viruses for their ability to infect human cells, and showed that, yeah, in fact, these viruses were able to do a quite good job at infecting cells. The problem with the study was in how they did their experiments. Those kind of experiments here in the US would be what we call biosafety level 3 or BSL-3 experiments. And that's where we work in a laboratory that has a special air handling system, special filtering systems. Investigators work with almost a full set of outer garments plus air protection so that we have a higher level of protection against potential exposure to these pathogens. The experiments in Wuhan were done at what we call biosafety level 2, which is something that people here in the US work on with, let's say, just regular seasonal influenza. It still has some safety positions put in place, but for instance, you don't need to have a respiratory protection for it. There are a few other things that you don't have to do. And what really became an issue is it really a good idea to work with a potential pandemic virus under those reduced biosafety level 2 conditions? I guess I should say, not to justify what the researchers were doing, but they were following the Chinese biosafety recommendations that said in China, they could do those kind of experiments at BSL-2. But here in the US, we would have to do that at BSL-3. And I think some US scientists were a little bit shocked about the fact that they were doing these experiments under that lower level of containment.
Mm-hmm. So there aren't worldwide standards for how to handle pathogens, I understand.
No, the NIH has a good set of standards that it utilizes for all NIH-funded research. And most institutions here in the US at least, use those NIH rules irrespective of what the funding source is for a set of experiments. But globally, every country can decide on its own where some of these rules are, and there is no global organization that can set standards that all countries have to adhere to.
Mm-hmm. That's worrisome.
Yeah, it is worrisome. I mean, we know that this kind of research is important, but we always want to make sure that we're doing it under safe conditions. And I think when people see that the same experiment is done under different conditions based on the country you're in, that naturally brings some questions into people's minds. And, this is the kind of research that we don't want people to really be worried about it. We want to be as safe as we can with this work.
Mm-hmm. So the different safety levels in labs from BSL-1, which is, I imagine, sort of a low level, all the way up to BSL-4. What do they do in a BSL-4 lab?
So best example of a BSL-4 lab is people who work on Ebola virus. Pathogens that go into BSL-4 usually have a very high mortality rate. They oftentimes have no cure or no antiviral treatment. And so therefore you want to be extra safe in terms of any experiments that you do. And again, BSL-4 is where you've seen scientists work around in those what look like almost like spacesuits, right? That show how really protected they are from the organism that they're working with.
hmm So this is about the researchers getting infected potentially, and then potentially bringing those pathogens out into the rest of the world.
Absolutely. Again, I want to be clear, even at BSL-2, we have safety considerations to prevent that. They just get greater and greater as the risk from the pathogen is perceived to be better and or greater and greater. A good example, I think, is, with SARS-CoV-2, for instance. At the beginning of the pandemic, we had to work with SARS-CoV-2 at those biosafety level 3 conditions because it was a new pathogen. We had no antivirals, we had no vaccines, and importantly, there was no pre-existing immunity in the population to it. So essentially, everybody was susceptible and we had no interventions. Recently, SARS-CoV-2 was brought down to a BSL-2 level. And again, that sort of makes sense now because all of us in the US, except for maybe some young children, right, have had some exposure to that virus through vaccines, through infection. We have vaccines available. We have antivirals available. For instance, I can tell people in my laboratory they have to get the annual COVID vaccine to work with COVID under BSL-2. So the virus itself poses much less of a risk than it did in 2019. And we have more interventions to protect the people working with it against potential exposures.
Regular seasonal influenza, I understand, can be under a BSL-2, but avian flu is under a BSL-3. Is that right?
Absolutely. And the same thing holds there. With seasonal flu, we have vaccines, we have antivirals, we even have testing, right, that we can do that give us additional layers of protection. But when people in my laboratory work with the H5 avian influenza virus, we do that in BSL-3 because we don't have vaccines. We do have some antivirals, but certainly we're not sure how effective they are against the H5. And we also know that H5 historically has caused more severe disease than seasonal flu. So again, those factors move the virus into the BSL-3 as opposed to BSL-2.
Feels like you have to really play with trade-offs here, right? So, we want to study these dangerous pathogens because of the potential they have to do so much damage. So we need to understand them. But at the same time, it's dangerous potentially. So where's the balance there?
And this is where we have a little bit of gray area, right? This is where discussions in terms of what the risks are, what the potential risks are, really become critical so that everybody is comfortable with whatever determination is made about the level of containment that you have to work with a virus. Like I said, for me, it's very clear that anything that causes a high mortality rate should be in BSL-3. If you don't have a vaccine against it, then that's another reason to put something in BSL-3 because those are things that you really want to be really careful with. But in some ways, there is a trade-off here because it costs a lot more to do experiments in BSL-3 than it does in BSL-2. As an example, it costs about $60 in disposable equipment for one of my people to enter a laboratory. And if they have to enter the laboratory 2 or 3 times a day to do experiments, suddenly we're paying $200 just for the protective gear on the outside. I'm not saying I don't want to do that. I'm just saying it's an additional cost that we wouldn't have to incur if we were doing those experiments at BSL-2. It also doesn't take into account the fact that the facility itself, with its HVAC and electrical and water control, is a very expensive facility to run. We have one here at the Bloomberg School of Public Health. And again, just the cost of maintaining that is much more than it is maintaining a regular BSL-2 laboratory.
Is it too dangerous for us to be studying these pathogens at all?
I really do feel like there's a lot that we could learn from some of these pathogens that would help us gauge the risk of animal viruses as human pathogens. Again, a lot of the containment that's used, a lot of this training that individuals get help us to minimize that risk. We can never get it to zero, but you can never have risk at zero for anything one does. But I think with these pathogens, we've really worked hard to get that risk down to as low as possible with the training and with the biocontainment facilities that we have available to us. And the knowledge that we gain from that is something that becomes very important for us in terms of our pandemic preparedness in the future.
Mm-hmm. So does it keep you up at night a little? Like what researchers in other countries are doing under what conditions?
Well, having gone through the COVID-19 pandemic, it's always a concern to me in terms of, what are the pathogens that are out there? As an example, those viruses that the Chinese investigators work with were essentially pulled from a cave. That cave doesn't have any biocontainment. It doesn't have any restrictions in terms of who can walk into that cave and who can walk out of that cave. And so to me, what it does say is that, those types of areas are a greater concern to the general public, and those represent those risks that we have to think about ways to mitigate as opposed to the work that's going on in the laboratory.
That's so interesting. So what do you do?
Well, this becomes a real important question, right? The investigators going into caves to sample viruses are all dressed up in their containment gear. Some of the times you can see these pictures, even in Africa these days, they're walking out of these things in their high containment gear, and they're walking right past locals who are walking by in shorts and a t-shirt, heading in the same direction as they just came from. So it's something that we have to just be really careful of. In some ways, this is a perfect example of that One Health approach to safety, which is, we have to think about things as the entire sort of global community that we interact with, taking account into factors including animals, our food, and the way we handle our day in, day out lives, because all of those things can help contribute to us minimizing risk of these new viruses entering the population.
Mm-hmm. And we're sitting here in a time when we are seeing a lot of cuts to research in the U.S., in U.S. foreign aid, et cetera. How does that change this equation, or does it?
Oh, it changes it tremendously. The best place to fight the next pandemic is on the ground in the places where we think the risk is highest. Right now we're doing that here in the U.S. with dairy cow avian flu, but globally, we have to have boots on the ground. We have to have capabilities locally to be able to fight and detect those new infections early, because we know that when we act early, we can contain things. When things spread too far, then it becomes a real problem for us in terms of using our normal interventions to limit an outbreak. So anything that happens that can limit our ability to be local, to be able to respond quickly, is going to make us less safe as a global community.
Mm-hmm. Might we see people maybe skimping on the protective equipment? I mean, are we in a time when cuts are going to be deep, or maybe we won't not skimp on equipment, it just might not be able to staff BSL-3 labs?
Yeah, I think it's more that latter point, Stephanie. I could speak from personal experience, right? We are cutting back our BSL-3 work because we don't have the funding to support it. And, again, rather than do things in a way that we don't feel comfortable doing, we're just stopping those projects, and we're preemptively stopping projects that we think could be helpful. But I think that that's the cost of some of the funding, is we're looking at the short term, but we're also seeing the long-term loss in knowledge and information that, again, will help inform us and keep up the facilities that are needed to respond to these new and emerging outbreaks.
And personally, I find it hard to believe that we would even be talking about this coming right off of a pandemic like COVID.
Absolutely. And we could probably talk for another hour about some of the politics and other things that go into this. But, the reality is the scientific response to COVID-19 really helped save millions and millions of lives globally. And, we should be strengthening that. We don't have to spend as much as we did during the pandemic, but we should be able to strengthen those so that we're at a higher level of readiness in case we have to respond to another pandemic. And if there's one thing that's certain, there will be another pandemic coming down the pipeline.
Andy Pekosz, thanks so much for joining me.
Thank you.
Public Health on Call is a podcast from the Johns Hopkins Bloomberg School of Public Health, produced by Joshua Sharfstein, Lindsay Smith-Rogers, Stephanie Desmon, and Grace Fernandez-Ciceri. Audio production by J.B. Arbogast, Michael Bonfils, Spencer Greer, Matthew Martin, and Philip Porter. with support from Chip Hickey. Distribution by Nick Moran. Production coordination by Catherine Ricardo. Social media run by Grace Fernandez-Sasiri. Analytics by Elisa Rosen. If you have questions or ideas for us, please send an email to publichealthquestion@jhu.edu. That's publichealthquestion@jhu.edu for future podcast episodes. Thank you for listening.